Today I'm going to be presenting 2008 AMC 12B problem number 23. The sum of the base 10 logarithms of the divisors of 10 to the n is 792. What is n? So the way we're going to solve this problem is, first let's split 10 to the n into 2 to the n times 5 to the n. And let's define a to be a number 0 through n, and b also to be a number 0 through n. So the factors of 10 to the n would be 2 to the a times 5 to the b. Or more precisely, 2 to the 0 times 5 to the 0, 2 to the 1 times 5 to the 0, 2 to the 2 times 5 to the 0, all the way until 2 to the n times 5 to the n. So that's a lot of factors, and that's a lot to say. The sum of the logs of the factors would be log of 2 to the 0, 5 to the 0, plus log of 2 to the 1, 5 to the 0, all the way until log of 2 to the n, 5 to the n, which is actually the log of the product of the factors. Because if you have a log of a number, any base, it's going to be the log of that same base times the product of the two numbers. So in this case, we can just multiply all the factors, and we get log default base 10 product of factors. And the product of the factors is 2 to the 0, 5 to the 0, 2 to the 1, 5 to the 0, 2 to the 2, 5 to the 0, all the way until 2 to the n, 5 to the n. This can be written as 2 to the 0 plus 1 plus 2 plus 3 till n to the n plus 1. This is because over here, in the beginning, let's split out 2 to the 0, 5 to the 0, 2 to the 1, 5 to the 0, all of that. Let's take 2 on one side and 5 on the other side. They're still will be multiplied together, but let's first simplify the powers of 2. So 2 to the 0 times 2 to the 1 times 2 to the 2 times 2 to the 3 all the way until 2 to the n. And then we have to do it again and again and again, n plus 1 times. I'll explain in further detail. So 2 to the 0 times 2 to the 1 times 2 to the 2 all the way until 2 to the n, when you multiply them, is going to be the sum of the exponents, which is 0 plus 1 plus 2 until n. And now we should exponent to the n plus 1 because for every 5 to the b, and b was any number 0 through n, as b increments from 0 through n, 5 to the b, for every 5 to the b, there's 2 to the 0 plus 1 plus 2 till n. So 5 to the 0, 5 to the 1, 5 to the 2, all the way until 5 to the n. And notice that's n plus 1 terms. So we have 2 to the 0 times 2 to the 1 times 2 to the 2 until 2 to the n multiplied n plus 1 times. So we have to further exponentiate that to n plus 1. And we do the same thing with 5, and we get 2 to the n plus 1 over 2 times n to the n plus 1 times 5 to the n plus 1 over 2 times n to the n plus 1. And by the way, we can do the same thing to 5 because they're both the same. 5 is no different than 2. According to the factor-wise. So then, now we have 2 to the n plus 1 over 2 times n to the n plus 1 times 5 to the n plus 1 over 2 times n to the n plus 1. And now let's also multiply the n plus 1 in there. So a rule of exponents is that if you have an exponent to another exponent, you can multiply the two exponents. So we multiply the two exponents, n plus 1 over 2 times n plus 1. And we get 2 to the n plus 1 squared over 2 times n times 5 to the n plus 1 squared over 2 times n. And now we multiply the base and keep the exponent the same and get 10 to the n plus 1 squared over 2 times n. Now that's the product of the factors. Now when we log that, we just get n plus 1 squared over 2 times n, because when you log something with a base and the thing you're going to log is that base to the power some number, the log of that will all be the number. So if you have log 10 and the thing you want to log is 10 to the n plus 1 squared over 2 times n, the log of that would actually just be the exponent because the bases, they match up. That's equal to 792. Now we still have more to go. Let's multiply both sides by 2, and we get n plus 1 squared times n is 1584. Notice n plus 1 is close to n, and n plus 1 squared would be close to n squared. So we could say n squared times n, which is n cubed, is close to 1584. So in this case, we can round n to be 10 or 11. When we make it 10, it's 11 squared times 10, which is 1210. Why I'm doing 11 squared times 10 is because this is just to help us. N cubed is roughly 1584. That's just approximation. We can't use it in the actual thing. The actual thing is n plus 1 squared times n is 1584. So if we find a value of n, we have to plug it into this equation, not this one. So it's 11 squared, which is 10 plus 1 squared, times n, which is 1,210, which is not 1,584, because it has to be equal. So let's try 11. So that's 11 plus 1, which is 12 squared, times n, which is 11, is 1,584. The reason n can't be 12 is because it's 1,728, which is more than 1,584. And we didn't take 9 because that looks too small. And 11 worked out just fine. So the answer of n should be 11, or A.